Hello explorers and welcome to another video. Today we're going to talk about the deriver model in Honcho. And when it comes to Honcho, there is a couple of different models. There is a deriver, a summarizer, a derivative engine, and also a dream engine that will take different metadata and figure out implicit and explicit facts about you. And we also have this kind of embedding model that tries to figure out small snippets of embeddings that could be used in order to search through your database and find the right information. But the deriver, instead of the derivative or the summarization, the only thing it does is pretty much read a conversation and then find small truths from that conversation. So if we have a text, it will look at the text and find small clues that it could say, okay, the current person we are talking about has a dog. That could be a very small thing that it could figure out. So it doesn't really need to be a large model for this, but it needs to be trained so it actually can respond in a very particular manner. It needs to respond with a particular speaker name has a particular trait, and then it needs to respond with a scoring of it, pretty much. So if we switch over to my screen here, I vibe coded some stuff and I put that on GitHub. So this is not my own code, but I ran it. It produced something, and I also trained on that something, and my deriver model, I'm pretty satisfied with it. I should go through all the different examples and see if it has found a couple of bad examples. And it also cost me a little bit to actually create its deriver. But let's go through it here. I'm not going to go through the full thing, but we have this kind of generate conversation thing, and it will go through and create synthetic conversations between two different persons. And it pretty much says that it's creating this scenario with two peers, and then they have the turn. That person says something, that person says something else. And when you want to run it, you install Anthropic and you export your own key, and then you generate conversation and you select the count here, and you will get an out conversation. And we see that it uses Claude Sonnet 4.6 here. We could upgrade it to a newer model, but it works pretty fine. And then we have a couple of examples of settings, of relationships, domains, and registers. And then we have a system prompts that adds all these things together in order to write these conversations. And we have some code here that actually does the thing. You can go through it if you want to on your own. But there is actually a better way, because this is asking one question and then another question and another question. And this could be pretty expensive after a while, because when you're sending each of them and get responses back directly, it's the rate that they have suggested on their page. But if you want to make it a little bit less expensive, you can actually batch it up. So they have this batch interface. This is the same kind of code. The only difference is that they are creating a batch. And so here we have the waiting for a batch. And when we create this batch and send it off, what it does is says, here you have 500 different questions that we have in one batch. And that batch, you can see that on Anthropic's homepage and see when it's done. And it should be done within 24 hours. So you will get a notice when it's done, and then you will get, you can run the script and it will fetch it back. So it's actually waiting for the process request here, and when it gets it back, it will write it down to a file. So if you are able to get it to be running for 24 hours and just wait for the response, I got my response in about 4 hours. So it didn't take that long. But when you do that, you get the half the price of the actual work. So it's a very subsidized kind of work. And of course, you can write these kind of conversation models for DeepSeek or any other of the models and get it down even more in price. But I chose to use Anthropic because the response is pretty nice and I got some information here. So when we have these conversations, we will have this kind of file. It shows the small one. I have a large one here as well. This large one I've trained is about 500 conversations, but the small one we have here, it's 5 conversations, so very small. And we have a setting here, a gym session, and then the mentor and the mentee, domain, family, and parenting, excited and rambling, and we have Rochelle and Damien. And speaker Rochelle, Damien, oh gosh, I'm so glad you're here today. I have so much to tell you. And then Damien, yeah, what's up? And then Rochelle, okay, you know Marcus has been doing travel soccer league for the weekends. My oldest is 11. Well, they last night. He has been selected for regional development squad and so on. So that is the conversation that it should get something out of. So if we look at the deriver data set, we have the same here with the batch and the normal, and it uses Claude Opus instead in order to figure this out. So when this is an you should extract explicit factual conclusions about the specific person from a conversation turn. Explicit conclusions are facts the person directly states or that are unambiguously presented in their message. Never guess, inferences, or speculation. So it's created a pretty strict prompt here. And then it runs through and created batches of this prompt as well for all my messages. And when we look at the result here, we can look at the training. So we see here we have 37 training messages, a lot of them. And then we have also about 9 evaluations from that we saw earlier. So if we look at this, here we have the full thing that we send over first, and then the conversation and things comes after. So here we have a conversation so far. Priya, okay, so you have to tell me about Japan trip because they literally have slept properly since I booked it and I don't, and so on. And then at the end here, we have the actual response. So you say that it's a salience of 5, and with one of the contents here is Priya worries 3 weeks away is too long to be apart from her mom. So that is the actual response. I created this GUI in order to go through all of these and see that all of the messages are factual. I'm not really satisfied with that GUI yet, so I'm not sure if I want to show that off, but it's something I could do. But then again, I think all the things that I've gone through so far, all the different things that it has derived are pretty much spot on. There isn't anything that is totally wrong. It's some things that are a little bit ambiguous, so could remove those, but otherwise it looks to create a pretty good list of training data here. So what do I do with this training data when I've done with it, when it has created all of this? So this is, we have some explicit prompt that says this is what you should have sent to you, and then we have a bunch of responses. This is what we expect you to respond, and that is exactly what is needed in Unsloth in order to train this model. So this could be sent exactly as it is into Unsloth and train a model. So if we switch over to Unsloth here, what I have done here is that I put in this training JSON here as a data set, and then we have the evaluation JSONL as an evaluation data set. So what you do is you go into train and then configure, and then you choose that over here. So it's just choosing files. You could choose a dataset from Hugging Face. There could also be an Amazon 3 bucket that you have your dataset at. But if you choose that, it will pretty much just download that dataset and put it in here. You could use recipes in order to create a dataset as well. And that is if you didn't write these scripts that I did, or use the scripts I wrote in order to generate data, you could use a recipe in order to generate data for your particular training. But what I wanted to train was this Qwen38B, which is pretty much the default model for this kind of options at the moment. And it could be trained with the QLoRa 4-bit, which works well for that. If we want to use a newer model, we might be required to use LoRa 16-bit instead, because it doesn't quantize well down to 4 bits. But this model, Qwen38B, does. So that's why I'm using it. And then you choose a number of epochs, and that is how many times it should go through all of your training data in order to train your model. Usually you use a lot of epochs here. I'm staying at about 30 because it actually hit a pretty good measure after just 30 epochs. So you didn't and what we need to know here, we don't train a totally new model. We are fine-tuning an already existing model. So that's why we can use fewer epochs. And then we have the content length, and this is, we are not expecting huge amount of content for this particular training set. So 2048 tokens or words is enough for this kind of training set. We could change any of these hyperparameters, of course. Adam 8-bit is a really good optimizer. And batch size, if you have a very little graphical memory, you could put that down to 1, for instance, and you will save a bit of a graphical memory because it doesn't load in more than one example at a time. It will take a little bit more time, of course. And I haven't changed anything on schedule. Memory checkpoint should be Unsloth, and assistant completions only. So that's pretty much it. And then I pushed start training, and when it had trained, I could just export it as a GGUF file. So this is what I trained before. Here we have this Unsloth, and if we look at this, we see that the training loss goes down pretty quick and then stays down here below the line. So it's pretty good. We could have run it for faster, but we see here at the end it starts to increasing loss again, which is not good. And we see that the training rate is also pretty good. Evaluation loss has also stagnated down here. So the what we get back from training more is not essential, pretty much. So here we have this export GGUF. We can click that again, and when we do this, we choose a particular endpoint here. So we have this training, and then we have 2 checkpoints. We could either take when it was actually done, or when it had run 30 checkpoints. So those should be exactly the same, but I had to read up what actually it meant. So this last one, the first one here is when it actually was done. So that's what the one that you want to choose, and then you just run the run this through and say that you want a GGUF for your AI, and in my case I chose this Q4KM. So I got about 4 gigabytes of model that I could run later on. And if we look back here in the repository, I've also added an example file for a model file. So this is pretty much it. We have a model file of this GGUF file. We have a temperature of 0.1 and a context of 4096. We could choose, of course, 2048 there instead, because that was what I said in the training. That could be one thing that I changed up. I could have changed it up to 4096. I don't remember. But it seems reasonable that that could be an option that I changed in the training. So then when you have that, you just use this in order to create a new model in Ollama, and then you can use it right off the bat as your Ollama deriver model in Honcho. So this was what I wanted to cover today. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you have any questions or suggestions, leave those in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.